Okay, so today I'm going to be looking at how soaps affect the surface tension of water. So I'm going to be using some nice hand soap, which is in short supply at the moment, and some peppercorns, and I've got my bowl of water here, and I've got a pestle and a mortar. So I put some peppercorns in here already, so I'm going to grind them up. Got nice granules. Okay, so I really like this experiment because it works so well. So I'll put them into the water. Okay, so one of the observations we're going to know is that the pepper is sitting on top of the water. There is some that is floated to the bottom, but they're quite heavy, but the majority of the pepper has floated on top. Okay, so what I'm going to do is I'm going to grab my soap. Okay, lovely Love Hearts smell. Some of my finger. And then what I'm going to do is I'm just going to pop my finger in. And as you can see, the pepper moves away. Okay. So, soap's still in my hand, still moving. Okay, and it goes into globules. So, why does it do this? Why does the pepper float? So, it is hydrophobic. Hydrophobic means it doesn't like water. So why is it not on the bottom? The water is held together by hydrogen bonding, which is an intermolecular force. And as you can see, I've got some water molecules here, and I've got the dotted lines show the intermolecular forces, the hydrogen bonds, between the water molecules. So this gives more surface tension on top of the water. So that's why they float on top of the water. But why does the pepper shoot to the side? We're using a soap. Okay, so soaps are salts made from alkaline hydrolysis of fats and oils. So a hydrolysis of fats and oils looks like this. So we've got a fat or an oil. We add sodium hydroxide, which is an alkali. That is why it is alkaline hydrolysis. And we get soap and glycerol. This is called saponification. So that is the process of making a soap. Okay, so why is this important? So for the example of the soap we're using, so we're using Carex Love Hearts, and as you can see from the ingredients, it says that it's aqua and then sodium lauryl sulfate. Okay, so sodium lauryl sulfate is like a soap, but it's actually called a detergent or surfactant, and it reduces the surface tension in the water. So as you can see here, I've got an example of what sodium lauryl sulfate looks like. And as you can see, we've got a negatively charged head here. And it is hydrophilic because it is negatively charged. And then an uncharged covalent tail, which is hydrophobic. Okay, so the hydrophobic tail, when we add this soap to the water, is repelled by the water. So therefore it shoots the pepper to the side along with it. And that is also why we get these kind of globules in the water as well. So if I turn it on like this, you can see that it has kind of clumped together. I've still got some soap in my hand to see if anything... Yeah, so it's still moving. Okay. So that is the action of soap. So this is the same, this kind of shows what grease will do as well. So grease as well will sit on top of the water. And then once you add that soap, it shoots away from the soap, and that is how we can get rid of the soap and break it down.